Good day from ChemHelp ASAP. We'll go through some examples of sp hybridized atoms in this video. Okay, so again we have a table of different molecules on the screen, and again we will start out on the right and consider our four starting valence atomic orbitals, s and the three p's. For sp hybridization, we simply need to involve two orbitals, s and p, in the hybridization, and that'll give us two new hybrid orbitals, two sp hybrids. Left over unhybridized orbitals are the two p's, the two remaining p orbitals, and those are still part of the orbital picture. So we started with four orbitals, four atomic orbitals, the s and the three p's, and in the end, after hybridization, we get out four atomic orbitals, two new sp hybrids and the two leftover p orbitals. Now let's work on our table. So our first molecule is acetylene. We have two carbons in this molecule, but they're identical, so we're just going to do one of them. Carbon number 1 is attached to two atoms, a hydrogen on the left and a carbon on the right. So we have A equals 2. We have no lone pairs, so A plus L equals 2. That means we have an sp hybridized atom. The geometry for an sp hybridized atom, which is attached to two atoms, is linear. And it has a bond angle, we predict a bond angle of 180 degrees. So our second molecule is called acetonitrile, and we have three atoms in this molecule, and we'll do all three. So starting with carbon number 1, we have four attached atoms, three hydrogens and a carbon. No lone pairs. Well, with four attached atoms, A plus L equals 4, and we actually need an sp3 hybridized carbon, so someone snuck in an sp3 atom on our sp video, which is fine. The geometry of this sp3 hybridized carbon with four attached atoms is tetrahedral. Tetrahedral, and our predicted bond angle would be 109.5. Now carbon number 2 is different. It has only two attached atoms to the carbon on the left and the nitrogen on the right. It has zero lone pairs, A plus L equals 2. That gets us where we should be with sp hybridization. The geometry is linear, and the predicted bond angle would be approximately 180 degrees. Finally, we have the nitrogen on the end of the molecule. It is a terminal atom, so we don't need to talk about its hybridization, but we are able to if we want to, and so let's just walk through it. It has one attached atom. That's the carbon to its left. It has one lone pair. A plus L equals 2. We could consider this nitrogen. sp hybridized. It, however, makes no sense to talk about the geometry of that nitrogen. It's a terminal atom. So there is no geometry to discuss, and there is no bond angle to discuss either. Regardless, we can still think about it as a hybridized atom if we wish. So those are just a few simple examples of atoms that have sp hybridization.